So the goal here for this question is we have a Cartesian complex coordinate, -8 square root of 3I, and we want to convert that into a polar complex coordinate. And the first thing I do for a lot of these problems is I like to think of it in a picture form. So you draw it out. So you have -8 square root of 3. So here we're going to have, this will be the complex axis, this will be the real axis, and on the real axis we have -8. So I think of that as -8 just real units. So vector just like that. Then we have square root of 3 imaginary I, just like this. The way I like to rewrite this then, so if I have a Cartesian coordinate like this, I would say that this is the same as -8 plus square root of 3I. And that way it's easier for me to visualize. All right, we do -8 this way plus 3 that way. And that's the way the complex plane looks. This is a similar concept as if we had something like 3, 4, where this would be the x value, that would be the y value. So then we would have 3 in the x direction, 4 in the y direction, and you could rewrite this as 3x plus 4y. So you have 3 x's and 4 y's. The little cap on top, that just means it's a unit vector, so it's just a distance of 1. So 3 times 1 in the x direction, 4 times 1 in the y direction, and that would give you right about here. Exact same concept in polar, except instead of having 2 real axes, x and y, we only have 1. We're just all real numbers, bam, right there. And then the imaginary numbers, right there. You can put it on more axes, but drawing gets more complicated, so not a big deal. So now that we have this picture drawn and equation written up, we want to find in polar. And polar is going to be in forms of r. I'll use a different color, purple. This will be r, and then I'm going to call this phi, so we could use theta. And we want to know this angle, and we want to know this radius. So to find the radius, not too bad. We take the square root, or the square, so r squared is going to be -8 squared plus square root of 3 squared. And we leave off the I, the complex component, because that's just telling us which axis to use. That's not really actually part of the number. So the square root of 3 is the distance within the complex plane. So we're not gonna put the I in there because that would make things more that'd be wrong. So you could also, maybe if you wanted, you could think of this I, you could put a little unit of REs in there, little real units, and then you'd leave that off just the way you're leaving the I off here, because that's just representing which axis to use. So long story short, 8 squared, square root of 3 squared, this gives us 64 plus 3, which is square rooted, which is square root of 67. Not too bad. Okay, so now we need to find the angle. So I'm going to find the angle here using SOHCAHTOA. Sine, cosine, and tangent. We have an opposite over here. We have an adjacent over here. So we're going to use tangent. Tangent of theta equals opposite over adjacent. So square root of 3 over 8. So that's going to tell us that theta equals, calculator, on mode, we're in degrees, second arctangent of second square root of 3 divided by 8, and that gives us 12.21 about degrees. And then to find phi, that's just going to be 180 minus theta, which is right there. So I'm going to say that phi, just another angle, equals 180 minus theta, because that's easier to write than 12.21. And then I'm going to go back to the calculator. 180 minus second answer, 167.78. And you can do this in radians if you prefer. I just like to use degrees because, I don't know, I feel comfortable with degrees. I enjoy degrees. But whatever form you need it in, put it in that form. So, long story short, putting this into polar form, we would then have square root of 67 and 167.78 degrees. And this would be polar form on the complex plane. And that would represent the same as -8 square root of 3i. So hope that helped give you a picture of how I approach these problems, and hope that helped. See you next time.